There is no empty space. This is not a metaphor, and it is not mysticism. It is among the most carefully tested propositions in the history of human knowledge, confirmed by instruments of extraordinary precision, confirmed again and again across decades, and it has not yet made its way into the ordinary picture of the world most people carry. The ordinary picture is wrong, not approximately wrong, structurally wrong, at the deepest level. What you call empty, the dark between the stars, the gap between your hand and the table, the stillness of a room at night, is not empty. It is full of something with no edges, no parts, no surface you could touch or point to, no threshold where it begins or ends. And yet it is, by the measurement, the most real and continuous thing there is. Physicists have a plain word for it. They call it a field. And before anything else is said, it is worth sitting with what that word actually means, not the popular version, but the precise one. A field is not a substance in the old sense. It is not made of smaller things. It is the thing the smaller things are made of. Picture the surface of deep water, not the water, the surface. A wave moves across it. The wave is real. You can measure it, photograph it, feel it lift you off your feet. But the wave is not a separate thing resting on the water. The wave is the water, briefly shaped. Take the water away, and the wave does not escape somewhere. It is gone. There was never a wave thing traveling through space. There was only water, briefly standing up, and then flat again. This is what the 20th century discovered about matter itself. Every particle ever measured, the electron, the photon, the quarks nested inside protons inside the atoms of the hand, lying still in the dark, is not a tiny solid object moving through empty space. It is a wave in a field, a raised place, a momentary thickening in something that fills all of space, that was here before the particle existed, and that will remain long after the particle is gone. There is no electron thing. There is only the electron field, briefly standing up. Lower it again, and the electron does not go somewhere else. It is gone. There was never a ball. There was only the field, and a place where the field lifted itself into a shape. A young Englishman named Paul Dirac first wrote the equations for this in 1927, working mostly alone, mostly in silence. He took the electromagnetic field, light, and showed that what we had called photons were not little stones flying through emptiness. They were the field's own trembling, counted out in whole numbers. The field could be raised by 1 unit, or 2, or 3. Each unit was a particle. The particle was not a thing inside the field. The particle was the field doing something. And this distinction, so quiet, so clean in the mathematics, quietly dismantled the entire picture of a universe made of objects. And here, the ordinary world comes apart. If a particle is only a raised place in a field, then what is empty space? It is the same field, lying flat, not absent, not nothing, the very same fabric, at rest. Matter and void are not two different substances. They are one substance, at two tensions. The full and the empty are cut from the same cloth, and cutting does not produce two things. It produces one thing, seen from two different states. But the flat field is not still. This is the part that resists easy settling. A field resting at its lowest possible energy is not a field at zero. The mathematics that describes it, the same mathematics that has never once failed an experiment, not one, across nearly a century of testing, forbids perfect stillness at the floor. The lowest state still trembles. There is a minimum energy beneath which the field cannot go, and that minimum is not silence. Physicists call it the zero-point energy. The trembling has a name that has since been badly misused: vacuum fluctuation. The void seethes. It cannot be made to stop. This is not a poetic description. It is a precise mathematical fact with experimental signatures. It is often said now, in certain corners of the culture, that once you truly understand the quantum field, your reality shifts, that the field is a vast reservoir of power waiting to be directed, that your thoughts and intentions ripple out into it and arrange the world to match. The claim physics actually makes is stranger than this and quieter, and it offers nothing to sell. The field does not take requests. It does not listen. It ran by the same equations for 13.5 billion years before anything existed that could formulate an intention. What is true is not that the field can be commanded. What is true is more unsettling than that. The one who would do the commanding is not standing outside the field, looking in. The one who would do the commanding is the field, briefly raised into a pattern that can ask questions. There is no you over here, and the field over there. There is only the field. And in this small place, in this moment, the field has arranged itself into a shape that is asking what the field is. That is the actual strangeness. Not that you can reach into the void and reshape it, but that the void and the reaching are the same thing, the same fabric, one piece at two tensions. You have lain still in a dark room late at night and felt the room not be empty, not as a thought, as a feeling, some quality of presence in the dark that could not be named and was not quite believable. Physics will not tell you what that feeling means, but it will tell you this: the room was not empty. The space around a still body, in the most literal and measured sense, is a continuous fabric seething with its own lowest energy, laced with correlations no instrument has ever fully mapped. The dark between the body and the wall is not the absence of something. It is the same fabric the body is made of, at rest. And rest is not nothing. Rest for a quantum field is still trembling. Knock on a table. It feels solid. It is almost entirely empty. Atoms are mostly vacant, the nucleus a small, dense knot in a vast cathedral of nothing. This much is often said. But the deeper truth is not that the atom is mostly empty space. The deeper truth is that there is no empty space inside it at all. What you called the emptiness is the field. What you called the solid speck is also the field. And the hardness felt when knuckle meets wood is not two solid objects refusing to pass through each other. It is two patterns in the same fabric declining to occupy the same configuration at once. The resistance is not a property of stuff. It is an agreement between raised places in the same medium. Solidity is not substance. Solidity is a relationship. There is a way to make this exact, and physics has made it exact. In 2012, beneath the French and Swiss border, in a tunnel so long it takes 11 minutes to walk its circumference, the largest machine ever constructed confirmed that all of space, every region without exception, is filled with a particular field predicted nearly 50 years earlier. It is called the Higgs field. It does not switch off. It does not thin out at the edges of things. It is everywhere with the same unvarying value, and the particles that move through it are heavy or light, depending only on how much they catch against it, the way a swimmer is slowed by water and a bird is not, though the analogy is imperfect, and the mechanism is exact. Mass, the weight of things, the reason a stone falls and resists being stopped, is in significant part a measure of how strongly a pattern of the field drags against another field, filling all of what was called The void. The void is not void. This is no longer hypothesis. None of the underlying question, though, is new. The physics is new, barely a century old, its most decisive confirmations still arriving within living memory. But the question underneath the physics is very old. Before anyone had measured a field, before anyone had written an equation for vacuum fluctuation or traced a particle's path in a detector, there were people in widely separated parts of the world, working in complete ignorance of one another, who arrived by entirely different roads at a conclusion that resembles this one: that the things of the world are not finally separate things, that what appears solid is appearance, not depth, that beneath it, or within it, or as it, there is something that is empty, and yet is not nothing, from which everything that seems to be a thing continuously arises and into which it continuously returns. They had no instruments. They had decades of disciplined silence, and what they found was not written down, mostly. What they found was passed from one person to one other, in rooms no historian ever entered, in a language that was not language. This night will return to them. Not to say they were doing physics before physics existed. They were not. Only to observe, carefully and without collapsing the distinction, that they were standing in front of the same shape, that the question they were pressing from one side, from the interior, through attention, and the question physics has pressed from the other side, through mathematics and measurement, have arrived at something that resembles the same architecture. The resemblance is real. It is also not what most people say it is. What is the ground? What is this fabric that is full when it looks empty and empty when it looks full, that rises into a particle and a person and a star and a thought, and then lies flat again? What is the thing doing all of this, running by the same equations in the dark between the galaxies as in the space behind the eyes of a person lying still in a quiet room, asking? And what does it mean that the one asking is not separate from what is being asked about? That the watcher is itself a wave on the same water, raised for a little while, looking at the water it is made of? The field was here before the first star condensed from it. It is worth taking a long time to ask what it is. The question entered physics in 1927, the way many important things enter, not through an announcement, but through a single man working alone in a Cambridge room, pressing a mathematical problem past the point where most people would have stopped. His name was Paul Dirac. He was 25 years old. He had already shown a capacity for sustained, silent, almost inhuman concentration. Colleagues would later remark that he seemed to think in a register most physicists could not access, as though the equations were visible to him in a way they were not to others. What he did in 1927 was take the electromagnetic field, the field whose trembling the eye sees as light, and ask a question that had not been asked in that form before. Not what is light made of, but what is the electromagnetic field described correctly in the full machinery of the new quantum mechanics that Werner Heisenberg and Erwin Schrödinger had just assembled? The answer he got was this: the electromagnetic field is a system that can be raised or lowered by discrete steps. 1 unit up, 1 unit down. Each unit, when counted, is what we call a photon. The photon is not a small stone flying through the field. The photon is the field, raised by 1. Turn off all the photons, lower the field to its ground state, the lowest energy it can possibly have, and the field does not disappear. It has not gone. It is simply lying flat. And it is from this flat, resting state that all the photons that have ever existed have come, and into which they all eventually fall back. The particle is what the field does. The field is what remains when the particle is gone. This sounds, written plainly, like a simple reclassification. It is not. What Dirac did was shift the fundamental ontology of physics, the answer to the question of what is real, from particles to fields. Particles became events. Events in something continuous. That continuous something is the field. And the field, unlike the particle, does not flicker in and out of existence. It is always there, in every region of space, in every corner of the dark between the galaxies. The field does not have places where it is absent. What is absent, in certain conditions, is the count of its excitations. But the field that would carry them is never absent. The ground is always there. This was 1927. The full understanding of what it implied would take another 3 decades. But Dirac was not finished with his one quiet year. In 1928, pressing further into the same framework, he wrote a new equation, one that merged quantum mechanics with Einstein's special relativity, describing the electron moving at any speed, up to and including speeds near the speed of light. The equation was elegant in a way that stops physicists mid-breath when they first encounter it. 4 numbers, arrayed in a particular mathematical structure, determining the entire behavior of the electron across all conditions. And it worked. It predicted the electron's behavior with precision, and then it gave back something no one had asked for. The equation had twice as many solutions as it should. For every solution describing an ordinary electron with positive energy, there was a mirror solution. An identical equation, equally valid, describing a particle with negative energy. The mathematics was not broken, but what it described did not exist in any laboratory, in any cloud chamber, in any experiment that had ever been run. Dirac sat with this for 3 years. Then, in 1931, he proposed something strange. The vacuum, what we call empty space, is not empty. It is a sea filled to capacity with electrons of negative energy, so densely and completely packed that they are invisible to any normal measurement. We cannot see them, because to see something requires the ability to push it into a higher state, and there are no higher negative energy states available. The sea is full. What we can see are the gaps. A place in this sea where a negative energy electron is missing appears to any experiment as a particle with positive energy and positive charge. An absence shaped like a particle. He called it an anti-electron, and he predicted it into existence. In 1932, Carl Anderson, working at the California Institute of Technology, found it. He was photographing the tracks of particles in a cloud chamber, a device in which charged particles leave visible trails in supersaturated vapor, curling in a magnetic field, when he saw a track that curved in the wrong direction. An electron curves one way in a magnetic field. This track curved the other way. Same mass. Opposite charge. Identical in every measured respect to an electron except for the sign of its charge. Anderson called it the positron. It was Dirac's predicted absence, made visible as a track in vapor in a Pasadena laboratory. Dirac's sea picture was, in its details, later replaced by a more refined understanding. The modern view does not literally hold that the vacuum is a sea of filled negative energy states. The mathematics of quantum field theory describes the same phenomenon differently, through what are called creation and annihilation operators, a cleaner accounting of the same structure. But the physical insight survived the refinement intact. The vacuum, empty space, the void, the nothing, has properties. It has the capacity to produce particle-antiparticle pairs when enough energy is deposited into a region. shine a sufficiently energetic photon into empty space, and the space produces an electron and a positron from nothing visible, as though the nothingness had been briefly strained, and two particles fell through the tear. The vacuum, under pressure, becomes matter. The matter, when the pressure relaxes, falls back into the vacuum. And what this implied was quiet and large at the same time. If the vacuum could produce matter, if it was not passive absence, but a substrate capable of dynamic response, then the vacuum was a physical object, not the backdrop against which physics happened, not the container, one of the objects. It had properties. It could be probed, and when it was probed at sufficient energy, it answered not with silence, but with particles. The picture was shifting. The mathematics was not announcing anything dramatic, but the picture, the inherited picture of solid things moving through empty space, matter against void, was being replaced at the foundations by something else entirely, not objects in emptiness, patterns in a plenum, raised places and absences in a fabric that is always there, from edge to edge of the universe, that was there before any of the patterns were raised into it, and that will remain after the last of them lies flat again. The trouble came almost immediately. When physicists tried to use the new field theory to calculate precise numbers, the energy of an interaction, the force between two charged particles, the mathematics did not return a finite answer. It returned infinity. Every calculation in the first version of the theory collapsed into a sum that grew without bound, not a large number, not approximately infinite, infinitely infinite in the technical sense, a series that diverges. The source of the problem was the vacuum itself. In quantum field theory, the ground state of a field contributes to every physical process. It does so at every scale of energy, at every frequency, all the way up, without cutoff. When you sum all those contributions, and you have to, because the theory says they are all present, the sum does not converge. The vacuum participates so completely at so many scales that the total is without bound. For almost 20 years, the field picture was in technical crisis. The intuition was right. The framework was deep. The predictions were infinite. And physics waited. What ended the waiting happened in 2 steps in the summer of 1947. The first step was a measurement. Willis Lamb, a physicist at Columbia University, announced at a small conference held at a resort on Shelter Island, New York, a gathering of 24 theorists and experimentalists, small enough that everyone knew everyone, a discrepancy he had found in the spectrum of hydrogen. According to the best existing theory, Dirac's 1928 equation, 2 particular energy levels of the hydrogen atom were supposed to be exactly equal. They were called the 2s1/2 and 2p1/2 states. Dirac's mathematics demanded they occupy the same energy. They did not. They were separated by a gap of roughly 1,000 megahertz, tiny in absolute terms, unmistakable by the precision of Lamb's apparatus. The gap was real. The gap had no explanation in the existing framework. The gap is called the Lamb shift. Willis Lamb would receive the Nobel Prize in Physics in 1955, in part for this measurement. What was significant was not just that the gap existed. What was significant was what had to exist to produce it. The Dirac equation predicted no such gap because it treated the electron in hydrogen as moving through a perfectly smooth electromagnetic field. But the new quantum field theory said the electromagnetic field is never perfectly smooth. At its ground state, it trembles. And a trembling field is not the same as a still one. The trembling reaches into the hydrogen atom and perturbs the electron, nudging it slightly away from where the smooth field calculation says it should be. One energy level is pushed up, another is pushed down. The gap opens. The vacuum had reached into the simplest atom in the universe and moved it. The second step came days later. Hans Bethe, the German-born theoretical physicist who had led the calculations at Los Alamos during the war and was returning his full attention to fundamental physics. Bethe heard Lamb's result at the conference and calculated its source on the train back to Ithaca, where he was then at Cornell. He did it by hand in the hours the train took, working in a notebook while the countryside moved past the window. He got an approximate answer. Approximate because he treated the problem non-relativistically, ignoring the effects of special relativity. The approximate answer matched Lamb's measurement to within a few percent. Bethe's calculation showed the way. The vacuum's trembling could be calculated, order by order, perturbatively. The infinities that had blocked every previous attempt could be systematically identified and absorbed into the definitions of measurable quantities, the mass and charge of the electron as they are actually measured in the laboratory, not the fictional bare values the theory would otherwise require. What is called infinite in one language is called a redefinition in another. The procedure was not clean, and Dirac himself never accepted it. But it worked. The resolution came from three directions at once. Richard Feynman, a young American physicist at Cornell who drew pictures of particle interactions on paper, pictures now called Feynman diagrams, developed a systematic way of accounting for the vacuum's contributions to every physical process, order by order, in a perturbation expansion. Each diagram represents a particular way the field can contribute to an interaction. A photon emitted and reabsorbed, a particle-antiparticle pair briefly raised from the vacuum and then returned to it, one more loop of vacuum activity added to the accounting. The diagrams are not pictures of what the particles literally do. They are terms in a calculation, a visual bookkeeping. But they made the structure of the theory visible in a way that allowed it to be computed. Julian Schwinger, working at Harvard in a formalism so dense with mathematical abstraction that even other physicists sometimes had difficulty following it, arrived at the same results by a completely different method, a continuous operator approach that did not require diagrams, that kept the relativistic structure of the theory manifest at every step. The results were the same as Feynman's, different notation, the same physics. Shinichiro Tomonaga, working in Tokyo during and after the war, with almost no access to current Western publications, isolated by geography, by language, by the devastation of the war years and then by the occupation, had developed the relativistic extension of quantum field theory independently, arriving at the same renormalization framework years before it was understood in the West, publishing in Japanese journals that few people outside Japan could read. His results, when they became accessible, matched the others completely. In 1949, Freeman Dyson, a young British mathematician who had come to Cornell to study with Feynman and then spent a long bus journey crossing the American continent, saw somewhere between the plains of Kansas and the desert of New Mexico that all three approaches were the same, that Feynman's pictures and Schwinger's operators and Tomonaga's equations were three notations for one theory. He published the proof. The three roads converged. The theory was unified and complete. It was called quantum electrodynamics, QED, and what it predicted, once the renormalization procedure was in place, was this: the magnetic moment of the electron, a measure of how strongly the electron responds to a magnetic field, could be computed from the theory by summing the contributions of all the ways the vacuum can participate in the electron's behavior. The computation at high precision requires hundreds of Feynman diagrams, each representing a higher-order loop of vacuum activity. The calculation took teams of physicists and later computers decades of sustained effort. The theoretical prediction to 12 significant figures is 2.023193043626. The experimental measurement is 2.02319304368082. These numbers agree to 12 decimal places. 12 decimal places. This is the most precisely confirmed theoretical prediction in the history of science. More precise than the prediction of planetary positions. More precise than the speed of light. More precise than any measurement of any kind that human beings have ever made. And the vacuum contributed to every digit of that agreement. Remove the vacuum fluctuations from the calculation. Set the ground state to 0. Assume the void is still, and the prediction diverges. The 12 digits of agreement are not in spite of the vacuum's trembling. They are because of it. The void is not noise in the signal. The void is the signal. There is a quality of stillness available in this fact, if it is allowed to settle. A measurement of a particle's response to a magnet, carried out in a laboratory with careful apparatus, agrees with a calculation done on paper to 12 decimal places. The calculation required knowing how the vacuum trembles. The trembling is so well understood that it can be calculated to 12 decimal places. And the trembling is real. It is there in the empty space of the laboratory, in the gap between the magnets, in the dark between the detector components, and it shapes the particle's behavior with a precision that should not be possible if the void were truly void. You have held a hand above a table and felt, or thought you felt, nothing between the hand and the wood. The nothing was not nothing. The nothing was, in the most precise sense physics can achieve, a trembling fabric whose properties were being calculated while someone half a century earlier was sitting on a bus crossing a continent, and the calculation agreed with the measurement to 12 decimal places. The gap between your hand and the table is the most precisely known nothing in the history of science. A year before the theory was complete, in 1948, a Dutch physicist named Hendrik Casimir was working in Philips research laboratories in Eindhoven when he proposed a small experiment of striking clarity. Take 2 flat metal plates, perfectly smooth, perfectly uncharged, placed very close together in a vacuum. No charge, no current, no springs or strings between them. Nothing that classical physics would recognize as a force. What does the vacuum between the plates do? Casimir's calculation said the plates would be pushed together. The mechanism was this. Between the plates, only certain wavelengths of the vacuum's fluctuations can fit. Long wavelengths are excluded by the geometry. They simply do not fit in the gap. Outside the plates, all wavelengths are present without restriction. This asymmetry, more vacuum activity outside the plates than between them, produces a net pressure pushing the plates inward, a force arising from nothing but the structure of empty space. The force was predicted exactly. The first careful measurement came in 1997, when Stephen Lamoureux, then at the University of Washington, confirmed Casimir's prediction to within 5%, using a torsion balance of extraordinary delicacy. Later measurements refined this to 1%. The force is real, and it is measurable. Here is where the honest account parts from the popular one. The Casimir effect is sometimes used as evidence that the vacuum contains infinite usable energy, that the void is a reservoir from which useful power can be extracted if only the right mechanism is found. This is not what the Casimir effect shows. In 2005, Robert Jaffe at the Massachusetts Institute of Technology demonstrated that the Casimir force can be derived without any appeal to zero-point energy at all. The force arises from the quantum properties of the conducting plates and the electromagnetic field's response to them. The same physics, expressed differently, without requiring the vacuum's energy to appear as an independent, harvestable quantity. The vacuum fluctuates. That is established. But the fluctuation is already at the floor. There is no lower state for it to fall to. No work can be extracted from something resting at its minimum. The Casimir plates are pushed together, and then they stop. The force is real. The battery is not. What the Casimir effect establishes, without overreach, is that the geometry of empty space has measurable physical consequences. The void is not passive. The void participates. This is enough. This is already more than the classical picture allowed. By the mid-1950s, the quantum field picture had been extended from light and electrons to every known particle and force. Not just one field, many fields. Each particle type is the excitation of its own field, pervading all of space in the same way the electromagnetic field does. The electron has a field. The muon has a field. The 6 types of quark each have a field. The W and Z bosons, which carry the weak nuclear force, have fields. The gluons, which bind quarks together inside protons and neutrons, have a field. And each of these fields, sitting at its ground state in the regions we call empty, seethes with the same irreducible minimum activity, the same trembling, the same refusal to be still. All of space, by mid-century physics, was understood to be the simultaneous ground state of dozens of overlapping quantum fields. Every region of what we call the void is threaded with this structure, every region seething with its minimum activity, every region ready to rise into matter if given the right input of energy. Matter is not distinct from the space it moves through. Matter is the space, locally raised. And then, in the late 1950s, the framework deepened in a direction that no one had quite expected. Yoichiro Nambu, a physicist at the University of Chicago who had survived the war in Japan and come to the United States carrying a physics so quiet and precise it sometimes took years for others to catch up with it, and Jeffrey Goldstone at Cambridge, working independently, demonstrated something about the ground states of certain quantum fields that changed the way physicists understood the vacuum. A field can have symmetries in its equations, mathematical regularities that treat all directions, all configurations as equivalent, and yet settle into a ground state that lacks those symmetries. The equations are symmetric. The lowest energy state is not. The example used to teach this is simple and imperfect in the way teaching examples always are. A pencil balanced perfectly on its point is symmetric. The equations governing it treat all horizontal directions as equal. But it cannot stay upright. When it falls in one direction, breaking the rotational symmetry not in the laws but in the outcome. The ground state, the lowest energy configuration, has chosen a direction the laws did not privilege. Nambu and Goldstone showed this happens in quantum fields too, and for deeper reasons. A field whose equations have a symmetry can settle into a ground state that violates that symmetry, not by accident, but by the dynamics of how energy minimizes itself. And when this happens, when a field breaks its own symmetry in settling, the result is the appearance of a new, massless particle, a ripple in the field associated with the direction of the symmetry that was broken. This is called a Goldstone boson. It is not a particle anyone placed in the vacuum. It is a consequence of the vacuum's choice. The ground state has structure, and the structure has excitations, and the excitations are particles that the theory generates automatically from nothing but the dynamics of how the void settles. The vacuum was acquiring depth Not just a seething minimum energy, a specific configuration, a preferred state, a shaped emptiness. This was both strange and productive, because a shaped vacuum is a vacuum that does things. A vacuum with a broken symmetry can transmit information about its structure to the particles moving through it. And if the vacuum can transmit structure to particles, if the properties of what moves through the void depend on the void's own configuration, then the void is not a neutral medium. It is an actor in the physics. A player, not a stage. Sit with this for a moment. The same vacuum that quantum electrodynamics showed leaves measurable fingerprints on hydrogen atoms, the same seething floor of minimum activity confirmed to 12 decimal places, turned out also to have large-scale structure. Not just local trembling, a global configuration chosen once in the early universe, maintained ever since, shaping the mass of every particle that has ever existed. The emptiness of space is not one thing. It is many things. Local fluctuations at the smallest scales, global structure at the largest, a fabric with texture at every level. This idea planted the seed for the last of the great confirmations. In 1964, almost simultaneously, 3 groups published the same mechanism. François Englert and Robert Brute in Brussels, Peter Higgs in Edinburgh, and Gerald Guralnick, Carl Hagen, and Tom Kibble in London. Each group, working from the logic of spontaneous symmetry breaking, proposed that all of space is filled with a scalar field, not a force-carrying field, not a matter field, but a field with the single property that its ground state is not zero. Everywhere, without exception. They proposed that in the early universe, this field had settled into a non-zero configuration and had remained there ever since, and that every particle that moves through this field acquires mass in proportion to how strongly it interacts with it. A particle with no coupling to this field, the photon, the carrier of light, is massless and moves at the maximum possible speed. A particle with strong coupling, the top quark, the heaviest elementary particle known, is very heavy because it drags powerfully against a field that fills everything called empty. Mass in this framework is not an intrinsic property a particle carries inside itself. Mass is a measure of how much a particle catches against a field that is everywhere, always, uniformly present. For 48 years, this prediction sat in the equations, confirmed only mathematically. Testing it required finding the field's own excitation, its particle, named the Higgs boson. And finding the Higgs boson required energies achievable only by a machine that would take decades to conceive, fund, and build. The machine is the Large Hadron Collider. It is buried in a circular tunnel 27 kilometers in circumference beneath the border of France and Switzerland. On the 4th of July 2012, the 2 independent detector collaborations at the European Organization for Nuclear Research, the ATLAS experiment and the CMS experiment, each involving thousands of physicists from dozens of countries, announced separately that they had found a new particle consistent with the Higgs boson, the right mass, the right decay channels, the right production rate. The field, predicted from the mathematics of a vacuum with structure, had been confirmed by the most complex scientific instrument ever constructed. The vacuum is threaded with a field, not metaphorically, measurably. The field is there in the space between the detector components, in the space between atoms, in the space between the stars. It does not switch off. It does not diminish with distance. It is the same everywhere, all the way out. Take a moment here, before the next layer opens. Take the measure of what has been assembled. What physics had built in the 100 years between Dirac's 1927 equation and the CERN announcement in 2012, was not a theory of particles in a void. It was a description of a single, restless plenum, one continuous fabric of overlapping fields, some at their ground states and trembling, some raised briefly into the configurations we call electrons and quarks and photons, all of them governed by equations that have not failed a single experiment across a century of increasingly fine-grained testing. The empty space of the world, the gap between hand and table, the dark between the stars, the silence of a room at night, is not empty. It is the ground state of this fabric. It is the fields, lying flat, seething at their minimum, every bit as real as the raised places we call matter, and made of the same thing. There is no void. There is only the fabric at two tensions. This is established. This is not speculation. This is what the numbers say, and the numbers have been checked by many people in many places across many decades, and they have held. The achievement is genuinely extraordinary. In the span of a single human lifetime, physics moved from a picture of small, solid things moving through empty nothing to a picture of a single continuous plenum with no empty regions anywhere, in which the solid things are temporary raised configurations of the same fabric as the nothing, and in which the nothing at its most resting state leaves measurable marks on everything it touches. The old picture was not wrong in its predictions at everyday scales. Stones fall, bridges hold, but it was wrong in its ontology, wrong in its account of what is real and what it is made of. What is real is the field. What is made of the field is everything. And what is remarkable, if one pauses at the edge of this, is that the same word, ground, appears in the technical vocabulary of both the physicist and the contemplative, in different languages, in different centuries, arrived at by methods that could not be more different, pointing at something that could not be more similar. The physicist's ground state, the lowest configuration of the field, the state from which all excitations arise and into which they fall back. This is not an etymology the physicist intended. It is not a metaphor the physicist is making. It is simply the word that fits, the word that physics chose, without knowing what else had used that word. The contemplatives will arrive later. Their languages belong to a different movement. But the shape they were reaching toward, in rooms of silence centuries before quantum field theory existed, was not as different from this shape as it should have been, if the two investigations had nothing to do with each other. But what the numbers do not say, what the theory, for all its precision, does not answer, is a different kind of question. Not what the field does, not how it behaves, not which equation governs it. Those questions have answers, and the answers work. What the theory does not answer is what the field is. Not in the sense of its properties, in the sense of its being, whether it belongs to a category of existence at all, whether the fabric is real in the way a stone is real, or real in a different way, or real in a way the word barely reaches, whether the ground is a thing, or an event, or a process, or a description. These questions do not disappear when the experiments succeed. They deepen. The better the theory, the sharper the edge of what it has not touched. And there are other anomalies that the theory produces not in spite of its success, but because of it. Places where the equations work perfectly and the implications are disturbing in ways no one has resolved. At that edge, the anomalies begin. For all that the foundation has established, there is one number it cannot explain, the quantum field theory that gave physics 12-digit precision, that correctly predicted the Casimir force and the Lamb shift and the Higgs boson, makes a prediction about the vacuum itself, about the total energy of the empty, resting ground state of all the fields. The prediction follows from the same mathematics that has been right about everything else. Sum the contributions of all the fields at all their allowed frequencies, add them up. The result should be the energy of the vacuum. The result is enormous. Enormous is too small a word. The theoretical value from the standard calculation exceeds the observed energy of the actual vacuum by a factor of 10 to the power of 120, not 10% too large, not twice as large, 10 to the 120th power too large. To write that number out in digits would require more room than the observable universe could provide. The observed vacuum has a tiny energy. It has been measured through its effect on the expansion of the universe. It is small, positive, and extraordinarily uniform. It drives the universe's accelerating expansion at a measured rate. Cosmologists call it the cosmological constant. It was first proposed by Einstein and later abandoned by him as unnecessary. It turned out in 1998 to be real and measurable, but its value does not match the quantum field theory prediction, not remotely. The gap between what the theory predicts and what the universe actually has is the largest quantitative discrepancy in the history of science, by a large margin. This is not a minor puzzle awaiting a technical fix. This is a fracture at the foundation. The theory that correctly describes the properties of empty space to 12 decimal places simultaneously predicts the energy of that space at a value that differs from reality by 120 orders of magnitude. Both facts are true. The theory works. The prediction fails. No one knows why. There are proposed explanations. Supersymmetry, which posits that every known particle has a partner particle not yet discovered, would cancel large portions of the predicted vacuum energy through a mathematical symmetry between the contributions of the two types, but supersymmetric partners have not been found. The Large Hadron Collider, which found the Higgs boson, has found no trace of supersymmetry at the scales where it was expected to appear. The proposed solution has not been confirmed, and the window for it is narrowing. There is the landscape of string theory, the idea that there are a vast number of possible vacuum states, each with a different energy, and that we inhabit the one whose value happens to permit galaxies and stars and physicists to exist. This is an anthropic argument, and physicists disagree about whether it is an explanation or an abdication. It is not confirmed. It may not be confirmable. The honest position is this: the energy of the vacuum, the energy of what we call empty space, is the most precisely observed quantity in cosmology and the least understood quantity in quantum field theory. The two measurements do not agree. Nobody has resolved the disagreement. This problem has been known since the 1960s. It remains open. There is something worth sitting with here before continuing. The theory that predicts the Lamb shift to 12 decimal places cannot predict the energy of the space the hydrogen atom sits in. Both are vacuum problems. Both involve the same seething ground state of the same fields. One is understood with extraordinary precision. The other fails by 120 powers of 10. This is not a minor inconsistency at the edge of the theory. This is the ground state of everything, predicted incorrectly by more margin than any number in the history of physics. The void is real. Its energy is measured. The theory that best describes its structure cannot account for that energy. Something fundamental, at the level of the vacuum itself, is not understood. There is something almost restful in admitting this. A century of extraordinary success in physics, predictions confirmed to precisions no other science can match, particles found exactly where the equations said they would be. and at the center of it all, a number that is simply wrong by 120 powers of 10, and no one knows why. The foundation has a crack. The crack is not small, and the crack is at the bottom where the void is, and here the anomalies deepen. In 1976, a Canadian physicist named William Unruh, working at the University of British Columbia, published a calculation with a result so strange that it took years for the physics community to fully absorb its implications. Unruh asked a simple question. An observer at rest in the vacuum measures no particles. The field is in its ground state, and the ground state, for that observer, is empty. What does an observer who is accelerating see? The answer the mathematics gives is not zero. An observer who accelerates uniformly through what the resting observer experiences as perfect vacuum finds the vacuum warm. Not metaphorically warm, thermally warm in the full technical sense. The accelerating observer detects a bath of particles distributed exactly as though they were in thermal equilibrium at a specific temperature. The temperature is proportional to the acceleration. Double the acceleration, double the temperature. Stop accelerating, and the warmth vanishes. The resting observer, watching the same region of space, still sees nothing. The same region of space. One observer, empty. Another observer, warm, full of particles. This result is called the Unruh effect. It has not been directly observed. The temperature for any acceleration achievable in a laboratory is far too small to detect. But it follows from the same mathematics as Hawking radiation, from the same framework as black hole thermodynamics, and the internal consistency of the calculations has been checked in many ways by many physicists over nearly 50 years. There is no identified error. The result is believed to be correct. What it implies is significant. The number of particles present in a region of space is not an absolute fact. It depends on the state of motion of the observer. An observer at rest and an observer accelerating through the same region will disagree about whether that region is empty. Both are correct. There is no observer-independent fact about how many particles are there. You can hold very still in a dark room and feel the room to be empty. Someone accelerating past you, by the same mathematics, would feel it to be warm. Both observations are accurate. Both are true statements about that room for that observer at that moment. Neither is more fundamental than the other. What this means for the nature of the field is not simple to state. The field is real. The equations are consistent. The observer dependence of the particle count is derived from those equations, not assumed. And yet the result is that the content of the vacuum is not fixed. It varies with how you are moving through it. This is unsolved. Not unsolved because we have not looked. Unsolved because the mathematics itself produces the result and then stays silent about what it means. And before continuing, it is worth pausing on a word that has been circulating in certain discussions of physics and consciousness for decades, a word that the Unruh effect sometimes attracts, the way a drain attracts water. The word is observer. In the Unruh calculation, the observer is a detector, a physical device, a thermometer. It is not a mind, not a conscious entity, not an act of attention. The accelerating observer could be a rock. The particle count would still differ from the resting observer's count. The effect does not require awareness. The word observer in physics is a technical term for any physical system that interacts with another. It was borrowed from ordinary language, and it has misled many people into conclusions the mathematics does not support. What the Unruh effect shows is something stranger and more precise than consciousness affects the vacuum. It shows that the properties of the vacuum are not absolute. They are relational, dependent on the motion of the measuring system. This is radical enough. It does not need the inflation. The real result is already disturbing. There is a related confusion about the vacuum that appears so frequently in popular accounts of quantum field theory that it has become part of the standard mythology. It is often said that the vacuum seethes with particles popping in and out of existence, that the void is a turbulent foam of particle-antiparticle pairs flickering into being and vanishing before they can be measured, constrained only by Heisenberg's uncertainty principle, which is said to allow brief violations of energy conservation. The picture is vivid. It is also not quite what the physics says, and the difference matters. Virtual particles, the term used for the internal lines in Feynman diagrams, are not particles in the sense of entities that exist and then cease to exist. They are terms in a perturbative calculation. When physicists calculate how two electrons interact through the electromagnetic field, they write the calculation as a series of diagrams, each representing a different way the field can contribute to the interaction. Each diagram is a term in a sum. Some of those terms contain internal lines, propagators, connecting different parts of the diagram. These internal lines are called virtual particles because they carry the quantum numbers of particles, but do not satisfy the relation between energy and momentum that real, observable particles satisfy. They are off-shell in the technical language. They are not observable. They are steps in a calculation. This is not a matter of them existing too briefly to detect. It is a matter of them being terms in a mathematical expansion, not objects in space. The distinction matters because the picture of particles popping in and out of existence is then used to argue that the vacuum has arbitrary amounts of energy available for extraction, or that the uncertainty principle permits the temporary creation of anything from nothing. Neither follows from the actual mathematics. The uncertainty principle does not permit violations of energy conservation. The virtual particles in a Feynman diagram are not borrowing energy from the vacuum and paying it back. They are terms in a sum. What is real about the vacuum is the zero-point energy, the irreducible, unremovable minimum activity of the field's ground state, and the effects that activity produces. The Lamb shift is real. The Casimir force is real. The corrections to the electron's magnetic moment are real. These effects are produced by the vacuum's ground state structure, and they are confirmed by measurement. The seething foam of particle-antiparticle pairs is a picture drawn from the vocabulary of the diagrams. It is not a window onto what the vacuum literally contains. The void is strange enough without the wrong story. The right story is stranger and more precise, and it does not offer what the wrong story promises. And the right story has one more piece that most popular accounts miss entirely. There is something worth pausing over before the next layer. The Unruh effect and the virtual particle clarification both do the same thing. They correct the inflation of the physics into something more dramatic than the actual claim, and they reveal in the correction something more genuinely strange than the inflated version was. The vacuum is not a reservoir of free energy. The particles in it are not literal, and yet the vacuum is full in a real, measured sense, and its structure is non-local in a way that the drama missed. The ground state of a quantum field, the vacuum, the empty, resting state, is not a collection of independent points. It is not a patchwork of small regions, each doing its own thing, stitched together into a whole. In 1961, two mathematical physicists named Rudolf Haag and Kazuhiro Araki established a result in the algebraic framework of quantum field theory that was later made more precise by several others and carries the name of the Riesch-Schlieder theorem. The theorem states something that is technically precise and difficult to state in non-technical language without losing the precision. Here is the attempt. Given any bounded region of space, any laboratory, any room, any patch of the universe, however small, there exist operations that can be performed on the quantum field confined to that region, which can produce from the vacuum any possible state of the entire field, including states in which particles appear in arbitrarily distant regions that are completely outside and causally separated from the original region. The vacuum state contains correlations that extend across all of space. Not correlations between particles. The vacuum has no particles. Correlations in the empty ground state itself. Correlations that mean the vacuum cannot be carved up into independent pieces. The emptiness is structured across its entirety. This is different from the entanglement between two particles that have interacted. That kind of entanglement is produced by a specific interaction between specific systems. What the Riesch-Schlieder theorem describes is a correlation that is present in the vacuum before any particles exist, built into the ground state as a structural fact, not produced by any event, not reducible to any local mechanism. The correlations are there in the nothing, as a feature of what nothing is. It is not possible to visualize this correctly. The standard tools of visualization, particles here, particles there, a signal connecting them, are the wrong tools for what the theorem describes. What the vacuum is, structurally, is a thing that does not decompose into separated parts in the way that classical empty space would. The emptiness is one thing. It is coherent across all of space. Its ground state is not the sum of many small ground states. It is one ground state, extended through everything, correlating everything, from inside its own resting structure. The dark room at night is not a collection of small darknesses. It is one darkness. And the quantum field theory of that darkness says the room is not separable into its parts, not because the parts are connected by something, because the room, at the level of its fields, was never divided. This result is not widely discussed in popular accounts of quantum field theory. It does not generate the visual drama of virtual particles or the narrative appeal of Schrödinger's cat. But it may be the most structurally significant claim the theory makes about the nature of the vacuum, that the empty ground state of the world's most fundamental description is a single, non-local, non-decomposable structure, not many small emptinesses, one emptiness, whole. And then the question that cannot be avoided, the field works. The equations describe it with precision that has not been equaled in any other domain of human knowledge. The Higgs boson was found. The Lamb shift was calculated. The magnetic moment of the electron was predicted to 12 places. Everything the theory has been asked to predict, it has predicted. But is the field real? Does the quantum field exist in the way a stone exists, with definite properties that are there whether or not anyone measures them, whether or not anyone has ever built an equation to describe them? Or is the field a device, a mathematical instrument of extraordinary accuracy that generates predictions, generates numbers that match measurements, and carries no additional claim about what is actually out there when no measurement is being made? This is not a question physics has answered. It is not even clear that physics, as a discipline, can answer it. The question is not about what the equations predict. It is about what the equations describe, about whether describing the field is the same as pointing to the field, or whether the description is a system for organizing experience that need not refer to anything beyond experience. The instrumentalist position has a long tradition in the philosophy of physics, traceable through Niels Bohr and back further. On this view, the purpose of a physical theory is to predict the outcomes of experiments. What happens between experiments? What is there when no one is looking? What the field is doing when no measurement is being made? These are questions the theory does not address and does not need to address. The theory speaks only about what can be measured. It is silent, appropriately, about everything else. The realist position holds that the silence is not appropriate, that a theory which works this well is tracking something real, that the field is genuinely there, that particles genuinely exist as excitations of it, that the vacuum genuinely seethes, that the Higgs genuinely fills space, that the extraordinary predictive success of the theory is evidence that the theory is, at least approximately, describing the furniture of the world. Both positions are held by serious physicists. The disagreement is not about the mathematics. The mathematics is the same for both. The disagreement is about what the mathematics is about, whether it is a map of reality or a map of possible observations. No experiment can settle this because the two positions predict the same outcomes for every experiment that can be run. This is not a failure of experiment design. It is a feature of the question. The question is not about what the field does. It is about what the field is, and what something is, as distinct from what it does, is the kind of question that data does not directly answer. The field works. Whether it is, the equations do not say. And the oldest wound in quantum theory did not close when the field picture arrived. It moved in. In ordinary quantum mechanics, the equation that describes how a quantum state evolves, the Schrödinger equation, is deterministic and continuous. The state unfolds smoothly, without interruption, carrying all possibilities forward simultaneously. A particle does not have a definite position. A spin does not have a definite direction. The wave function holds all the possibilities at once, each with a weight, and the whole structure evolves according to the equation, without collapse, without selection, without anything in the mathematics forcing a single outcome to be the one that occurs. And then a measurement is performed, and one outcome is found. The theory, taken at face value, does not explain this. The Schrödinger equation gives no account of why one outcome occurs. It gives no mechanism by which the smooth evolution of many possibilities becomes a single actual result. This is called the measurement problem. It has been open since the late 1920s. In the field picture, the problem does not disappear. The fields evolve in superposition. The measurement device, made of fields, enters superposition with the measured system. The room, made of fields, enters superposition with the device. Everything evolves together, without collapse, without selection, without any term in the equations that would cause one branch to become real and the others to not. The field picture contains the same wound. It is simply larger now. There are more fields in the superposition. There are proposed resolutions. The many worlds interpretation, developed by Hugh Everett at Princeton in 1957, holds that all outcomes occur, that the wave function never collapses, that what looks like a selection is a branching of the entire universe into separate, non-interacting versions. The physics is consistent. The implication that every quantum event spawns new instances of the entire universe is not confirmed by any experiment, because no experiment can look across the branches. It cannot be ruled out for the same reason. The objective collapse models, developed by Giancarlo Gherardi, Alberto Rimini, and Tullio Weber in Trieste in 1986, and extended by Roger Penrose, who added a proposed gravitational threshold for collapse, propose a modification of the Schrödinger equation itself, an additional term that causes the wave function to collapse spontaneously at a rate negligible for small quantum systems but decisive for large ones. These models make predictions slightly different from standard quantum mechanics at certain scales. Those predictions have not been confirmed. They have not been ruled out. The experiments capable of testing them are at the frontier of current technology. Cubism, quantum Bayesianism, developed by Christopher Fuchs at the University of Massachusetts and his collaborators, holds that the wave function is not a physical object at all, but a record of an agent's expectations about future experiences. There is no collapse because there was never a physical wave to collapse. There is only a rational agent updating their beliefs in the light of new experience. What the world is doing between measurements is not a question the theory addresses, because the theory, on this reading, was never about the world. It was about the relationship between an agent and the world. No interpretation has achieved consensus. No experiment has decided between them. The mathematics is the same in all of them. What differs is what the mathematics is taken to describe, what it is about, and whether it is about anything at all in the sense that physics has traditionally been about things. This is the honest position, not a temporary gap in understanding, a genuine open question about the foundations of the most successful physical theory ever constructed. And so physics arrives at this place. The theory is extraordinarily precise. Its predictions are confirmed. And at its foundation, threaded through its equations, are questions the theory cannot resolve. Why the vacuum energy is what it is, what it means that particle counts are observer-dependent, whether the field is a thing or a description, why any single outcome ever occurs. These are not gaps left by ignorance. They are gaps opened by the theory's own depth. The equations reach down to a level where the questions change form, and the new questions do not have the same kind of answers the old ones did. Physics has built, with extraordinary care and precision, a structure that touches something the structure cannot fully hold. The measurements are right. The predictions are right. The interpretation is open. And the openness is not an embarrassment. It is the most honest thing physics has ever said. What is the ground? The question has been carried to the edge of what the equations can say. And at that edge, it turns out, the question has been waiting in a different language, approached by a different road, for a very long time. Not the same question asked twice, the same shape reached from two opposite directions. The physics came from the outside, through measurement and mathematics. Something else came from the inside, through silence and attention. And they have arrived, independently, at this, that the ground is not empty, not divisible, not fully visible to the methods that find it. Before physics could measure a field, certain people were already asking the same question, not with instruments, not with equations, with decades of sustained attention, directed inward in rooms of silence, in caves, in monasteries built at the edges of inhabitable land, by disciplines so demanding that most of what they found was never written down at all. They were asking, what is the ground? What is the thing from which all appearances arise and to which they return? What is the substrate beneath the solid world? They used different methods. They arrived by different roads. They used different languages, different conceptual frameworks, different cosmologies shaped by different histories and different cultures, separated by thousands of miles of land and sea. They did not know about each other. In most cases, they were not in correspondence. There was no shared vocabulary. and yet certain structural features of what they've found recur with a constancy that is difficult to dismiss. Not the surface details. The surface details are very different. The deep architecture, the shape of the answer under the cultural clothing before the local vocabulary arrives to dress it. What follows here is not a claim that they discovered physics before physics. They did not. What follows is an attempt to describe the architecture of what several of them found, and to observe, carefully with the discipline the observation requires, that it resembles the architecture of what physics has been describing from the other direction. The languages are different. The methods are different. The structure is the same. This is not a merger. It is a recognition. There is a school of Buddhist philosophy, founded in India in the 4th and 5th centuries, that proposed something which most popular accounts of Buddhism either ignore or misrepresent so thoroughly that what they describe bears little resemblance to the original. The school is called Yogacara, sometimes translated as the Yoga Practice School, sometimes as the Mind-Only School, a name that has caused more confusion than it has resolved. Its founding figures were two brothers, Asanga, who received its central teachings and systematized them, and Vasubandhu, who may be the most important technical philosopher Buddhism ever produced, and whose work in the 5th century laid out in precise logical detail a structure of mind and world that took Indian philosophy centuries to fully absorb. What Yogacara proposed is this: under the surface experiences of an ordinary life, seeing, hearing, thinking, feeling, wanting, and under the 7 functional modes of consciousness that process and sort and react to those experiences, there is an 8th. It does not perceive. It does not react. It does not think. It is a substrate, a ground layer of mentality that underlies all experience without being any experience in particular. Asanga and Vasubandhu called it the storehouse consciousness, the all-base, in Sanskrit the storehouse, alaya vijnana, and they proposed that all the surface experiences of a life, all the perceptions and reactions and intentions arise from this substrate the way waves rise from a depth of water and subside back into it and leave in it traces, the way a pond, disturbed, gradually carries the disturbance in its depths long after the surface has settled. The structural parallel to what the previous sections of this account have described is not subtle. A substrate that is primary. Events arising from it. Events subsiding back into it. The substrate persisting through the arising and subsiding, unchanged in its essential nature. This is the architecture of the quantum field. Substrate primary, particle derivative, field persisting through the coming and going of every excitation. The Yogacara account goes further, though, in a direction that the substrate parallel does not fully capture. Between the storehouse and the surface experiences of seeing and hearing and thinking, there is a 7th consciousness that Vasubandhu describes as the constant, unnoticed presumption of a self, a continuous background operation of the mind that takes the storehouse as its object and mistakenly identifies it as a permanent, unified self, a center of experience that persists unchanged through all the changes in experience. This 7th consciousness, called the afflicted mind, manas, is not noticed by ordinary introspection. It is not one of the surface experiences. It operates below them, continuously, generating the deep feeling of being a separate self, whose boundary is the body and whose contents are the mental stream. What is being described is an error built into the architecture, not a mistake in reasoning, a structural feature of how ordinary consciousness operates, mistaking the substrate for a self, generating the sense of separation from what is around it. experiencing the field's own ground state as if viewed from outside by a separate observer. The cure in Yogacara practice is not the acquisition of new knowledge, but the recognition of what was already there. The storehouse is not a self. The continuity is real. The center is not. The physics parallel does not extend this far. Physics does not have an account of the error of selfhood. But the structural feature, a substrate mistaken for a thing among things, a ground that appears to be an object only because the instrument doing the looking is itself made of the same ground. This has a family resemblance to the measurement problem at the heart of quantum theory. The measurer is made of the field. The measurement cannot stand entirely outside the field. The apparent objectivity of the observation is itself conditioned by the fact that the observer and the observed are excitations of the same substrate. But here is where the popular version of Yogacara goes wrong. And it goes wrong in a way that matters because it converts the teaching into its opposite. It is often said that Yogacara is the school that claims the world is made of mind, that external reality is a mental projection, that the physical world does not independently exist, that consciousness creates the world. The popular rendition turns the storehouse consciousness into a kind of cosmic mind that one can access, reprogram, or align with, a reservoir of mental power waiting to be tapped for the transformation of experience. This is not what the tradition teaches, and the tradition spent centuries, formal debates, scholarly polemics, careful distinguishing texts, warning against exactly this reading. The storehouse consciousness is not a cosmic universal mind. It is not a self. It is not an entity. Vasubandhu himself, in a text called the 30 Verses, Trimsika, is meticulous on this point. The storehouse is not a permanent, enduring self that underlies experience. It is a stream, a continuity without a substance at its center. The great later commentator Dharmapala, writing in the 6th century, devoted considerable effort to distinguishing the storehouse from any form of permanent ground or unifying substance, precisely because the mistake of reifying it into a self was one the school's critics had made, and one it feared its own students would make. The popular account that converts the alaya vijnana into a cosmic reservoir of mental power commits exactly the error the school's greatest thinkers spent centuries warning against. It is not a subtle misreading. It is the inversion of the teaching. What the tradition actually proposes is more careful and more strange. There is no stable substance at the base of experience. There is a process, a stream, a momentary arising and subsiding, with no fixed center, no permanent self, no cosmic mind presiding over the whole. The substrate is real. The substrate is not a thing in the ordinary sense. This is the harder claim. The physics of the vacuum, too, is not nothing. And yet it is not a thing in the ordinary sense either. The parallel is structural. The methods differ. The languages do not begin to overlap. And then, from a tradition at the other end of the Buddhist world, in Tibet in the 14th century, from a teacher named Longchenpa, whose full name is Longchen Rabjam, which means something like the vast expanse of all phenomena, comes the most precise structural parallel in this entire account. Longchenpa was a scholar of extraordinary breadth who worked within the Nyingma school of Tibetan Buddhism in the tradition called the Great Perfection. In Tibetan, the vast expanse, Dzogchen. He wrote texts of unusual depth and technical precision, including a vast series called The Treasure of the Dharmadhatu and a work called The Treasury of the Natural State, among others. What he articulated drawing on a transmission lineage that traced back through centuries of oral instruction before him, is a distinction so fine that most translations and most popular accounts simply collapse it. The distinction is between ordinary mind and the ground itself. In Tibetan, the ordinary grasping, reactive, conceptual activity of consciousness is called sems. It is what most people think of when they think of mind, the stream of thoughts, reactions, intentions, emotions, the inner monologue. And then there is what lies under that stream, not as a deeper mental activity, but as the basis of the capacity for experience itself. Longchenpa calls it the ground, Gji, and its luminous, aware quality he calls Rigpa, pure presence, pure awareness, not directed at any object, not associated with any content, not produced by any cause. The ground, Gji, is taught in Dzogchen with three inseparable qualities. It is empty in its essence. There is no substance at its center, no object you could point to and call the ground. It is luminous in its nature. It is not blankness or absence, but a quality of knowing presence that cannot be reduced to not knowing. And it is unobstructed in its display. Everything that arises, all the appearances of the world, arises from it without obstruction, the way a clear mirror reflects everything placed before it, without becoming any of those things, and without being diminished by the reflecting. This is the teaching the texts can point at. What the texts cannot convey, and what the lineage has been at pains to transmit across centuries precisely because the texts cannot convey it, is the distinction between Rigpa and the ordinary mind as a lived recognition rather than a conceptual category. The Dzogchen tradition is explicit that this distinction cannot be arrived at by study alone, that it requires direct introduction from a teacher who has themselves recognized it. The difference between knowing about Rigpa and recognizing Rigpa is, in this tradition, the entire gap between theory and practice. The texts are fingers. They point. The recognition is the moon. The structural parallel to the vacuum is precise, and it requires care not to collapse it into identity. The quantum vacuum is empty at its ground state, and yet its ground state is not nothing. It seethes with its minimum activity. It trembles at the floor. It holds correlations across all of space, without a separate substance to hold them. The Dzogchen ground is empty in essence, and yet its emptiness is luminous. It is the ground of luminous knowing presence, not the absence of knowing. Two descriptions of a ground that is empty and yet not nothing. Two arrived at by methods that could not be more different, one through mathematics and measurement, one through silence and sustained self-inquiry. The languages are different, the methods differ. The structure, empty at the base, yet not vacant, ground of arising without being itself a thing, is the same. What the tradition explicitly does not say is what the popular version often claims, that the ground is a blissful void, a cosmic emptiness to sink into, a meditative state of blankness. This is precisely what the three qualities, empty, luminous, unobstructed, are designed to prevent. The ground is not blank. It is not an achievement of mental emptying. It is what is there when the ordinary grasping mind relaxes its grip. It does not need to be produced. It cannot be produced. It is the basis from which the ordinary mind continuously arises and into which it continuously returns, whether or not the ordinary mind notices. The vacuum did not need the Higgs field to be installed. The Higgs field was always there. The vacuum does not need to be prepared. It is the ground. The structural echo, held carefully, without collapse, is real. And here, a very old text, from a tradition even older than the Buddhist schools, approaches the same architecture from a completely different angle. The Tao Te Ching was written, attributed at least, to Laozi, a figure whose historical existence is uncertain, in China in the 5th or 4th century before the Common Era. It is 81 short chapters, many of them compressed to near opacity, resistant to any single reading, and productive of two great commentaries that arrive at readings so different they might almost be describing different texts. The character of the Tao is announced at the beginning and refused at the same moment. The way that can be spoken, it opens, is not the eternal way. The name that can be named is not the eternal name. What is described in the first line is a limit of description that the text will then spend 80 more chapters approaching, circling, and declining to cross. And woven through those chapters is a concept that has been essential to Chinese philosophy since the text was written. Non-being, emptiness, the useful void, in Chinese Wu. Chapter 11 makes the usefulness of emptiness as concrete as it has ever been made. The 30 spokes of a wheel meet at the hub, and it is the hollow in the hub that makes the wheel usable. Clay is thrown to make a vessel, and it is the hollow inside the vessel that makes it useful. Walls and roof are raised to make a room, and it is the empty space inside the room that makes it habitable. The chapter ends with 8 words. Therefore, what is solid is useful, and what is not solid is what is used. Being gives function. Non-being gives use. Wu, the emptiness, is not the absence of the thing. It is the operative part. It is the part that does the work. And here, the two great commentaries divide in a way that most popular accounts collapse. Wang Bi, writing in the 3rd century of the Common Era, reads this passage and the Tao itself in a particular way. For Wang Bi, Wu, non-being, is the ontological ground of all being. It is a metaphysical nothing that is not merely the absence of things, but the source from which all things arise. Being depends on non-being. The 10,000 things of the world depend on a ground that is not a thing. This is a reading in the tradition of what Chinese philosophy calls the mysterious, and it produces a Tao that is an absolute ground of being, somewhat in the spirit of Aquinas's ipsum, esse subsistens, the self-subsisting act of being, or Eckhart's Godhead. He Shanggong, who may have commented earlier but whose text circulated widely in the Han Dynasty, reads the same passages differently. For He Shanggong, the emptiness is not metaphysical absence but the vital breath, the cosmic generative force, the teeming, dynamic nothingness that breathes out the 10,000 things in a continuous process of generation. The void is not still. The void is the source of the motion. The emptiness at the center of the wheel is not metaphysical. It is functional, vital, procreative. 2 vacuums from one text. One still and absolute, the ground of being. One dynamic and generative, the breath that makes. Both arrived at by reading the same 81 chapters. Physics has the same split. The vacuum as ground state, as the absolute lowest energy configuration from which everything is measured, the mathematical zero from which all excitations are counted. Echoes Wang Bi's still absolute non-being. The vacuum as seething field trembling at its minimum, generating particle-antiparticle pairs when struck, producing the Casimir force, leaving fingerprints on hydrogen atoms. This is closer to He Shanggong's dynamic, generative breath. Both are descriptions of the same vacuum. The distinction is emphasis, angle, language. The object, if the vacuum is an object, remains singular. The convergence is not proof. The Taoist commentators were not doing physics. Wang Bi had no knowledge of quantum fields. What is being observed is something different, that the same structural tension between a void that is still and a void that is active, between a ground that is nothing and a ground that generates everything, appears in independent investigations separated by 2,000 years and every conceivable cultural and methodological difference. This is not coincidence, and it is not prediction. It is the same shape, seen from two different positions, described in two different vocabularies. The languages are different. The methods differ. The structure is the same. And from the other end of the world, in Andalusia in the 12th and 13th centuries, a Sufi mystic named Muhyiddin ibn Arabi proposed something that the mainstream of Islamic jurisprudence found so troubling that orthodox scholars spent 6 centuries attempting to refute, marginalize, or carefully domesticate it. Ibn Arabi's central teaching, the unity of being, in Arabic wahdat al-wujud, is often summarized as pantheism, the claim that God and the world are the same thing, that everything is God, that the multiplicity of appearances is an illusion masking an underlying divine unity. This summary is not wrong in the way that some popular misreadings are wrong, as an outright inversion. It is wrong in the way a half-understanding is wrong. It captures the conclusion and misses the mechanism. What Ibn Arabi actually proposes is more precise and more disturbing than the summary suggests. It is not that the world is God. It is that the world is God's ongoing self-disclosure, and that this self-disclosure is not a single act, not a creation that happened once and then remains in existence, but a continuous, moment-by-moment renewal. In Arabic, the doctrine of the renewal of creation in every instant, tajdid al-khalq fil anat, holds that the cosmos is annihilated and recreated at every moment. Not that things change gradually, that they are wholly remade, instant by instant, each thing a new self-disclosure, each moment a new exhaling through what Ibn Arabi calls the breath of the compassionate, nafas al-Rahman. Nothing endures between instants. The stone that appears to persist from one moment to the next is, in Ibn Arabi's metaphysics, a new stone in each instant, freshly disclosed from the same ground, so rapidly recreated that the continuity is an appearance and not a substance. The world has no persistent stuff. It has only the continuous, uninterrupted renewal of the same self-disclosure. The structural parallel to quantum field theory is among the most striking in this entire account. What physics describes is a world with no persistent particles, only fields and excitations of fields, and excitations that arise and subside continuously from a ground that persists through all the comings and goings. The electron that exists now is not the same electron that existed a moment ago, in the sense of a persistent ball moving through space. It is the electron field in this configuration at this moment. It has no enduring substance beneath the configuration. There is only the field, continuously displaying itself in this form. The languages are not the same. Ibn Arabi speaks of God and self-disclosure and the breath. Physics speaks of fields and excitations and ground states. The methods are not the same. Ibn Arabi arrived at this through contemplative practice, visionary experience, and a close reading of the Quran that most of his contemporaries considered heretical. Physics arrived at it through particle accelerators and perturbative calculations. What is the same as this? No persistent substance, continuous renewal, a ground that gives rise to each moment without being diminished or altered. The world is process rather than collection of things. And here, the popular version must be dismantled with some care. Ibn Arabi is sometimes invoked in discussions of quantum physics as though his teaching confirms that all things are one, that the apparent separateness of individuals is an illusion, that beneath the surface everything is unified in a single divine substance. This is the comfortable version. It requires precision to displace. Ibn Arabi does not say there is a single substance, with things being its modifications. He says there is continuous self-disclosure, with each disclosure being genuinely new. This is not unity in the sense of things being the same thing underneath. It is unity in the sense of arising from the same ground, the same source of disclosure, and that ground is not a substance at all, in the sense that physics would use the word. It is what Ibn Arabi calls the absolute, which he distinguishes carefully from anything that can be named, described, or conceptualized. The unity of being is not the claim that everything is one thing. It is the claim that everything is one disclosure, one ongoing exhaling of a ground that is itself beyond description, beyond the reach of any concept, including the concept of unity. This is considerably more demanding than everything is one. It is also considerably closer to the structure of what quantum field theory describes. Not a single thing, but a single ground of arising, from which each moment is freshly produced, without anything enduring between the productions. And then, from India, in a text so compressed that its 13 verses have produced centuries of commentary, the Isha Upanishad, one of the earliest of the Upanishads, composed perhaps in the 7th or 8th century before the Common Era, and placed first in many traditional collections of the 108, opens with an image that is among the most structurally precise in any contemplative literature. The invocation is simple. That is full. This is full. From the full is taken, and the full remains. In Sanskrit, Purnamada, Purnam idam, Purnat Purnam udachyate, Purnasya Purnamadaya, Purnam evavashishyate. Fullness takes from fullness, and fullness remains. No depletion, no subtraction. The source is not diminished by the arising of what arises from it. Shankara, the 8th century Advaita Vedanta philosopher, who wrote perhaps the most influential commentary on the Upanishads, reads this passage through his non-dual framework. The fullness is the nature of Brahman, the ground of all being, which is infinite. Not infinite in the mathematical sense of being very large, but in the sense of being uncountable, having no parts that could be taken from it, generating all appearances without losing anything. From this ground, the apparent multiplicity of the world arises, but nothing is actually removed from the ground. The multiplicity is not a subtraction from the fullness. The appearances do not deplete the source. The parallel is to the vacuum, to the seething ground state of all the quantum fields, from which particles arise and into which they subside, without the vacuum ever being spent. A particle is created. The vacuum is not diminished. The particle is annihilated. The vacuum is not increased. The ground persists through all the excitations that arise from it, unchanged in its essential structure, indifferent in its ground state to how many times it has been raised and lowered. The Advaita tradition's name for the ground, Brahman, from a Sanskrit root meaning to expand or swell, already carries the sense of fullness that overflows without depleting. Shankara's distinction between Brahman with attributes, available for worship and relationship, and Brahman without attributes, the ultimate ground beyond all qualification, echoes the physicist's distinction between the field in particular configurations and the ground state that underlies all configurations. Both distinctions point to the same structural feature. a ground that is real and primary, from which all the qualified, specific, named things arise, and which is itself not among the things that arise from it. Physics did not confirm the Isha Upanishad. The Isha Upanishad did not predict the vacuum. They arrived at the same architecture by methods separated by 2.5 millennia, and every conceivable difference of culture, language, and investigative discipline. The convergence is structural. It is not proof of either. It is recognition of a shape. And from medieval Europe, from a Dominican friar in the Rhineland whose sermons were densely packed with claims so precise and so unusual that they attracted the attention of the Inquisition, comes a brief but exact echo of the same ground. Meister Eckhart, the preacher whose sermons in Middle High German at the beginning of the 14th century were attended by thousands and who was condemned on 28 propositions by the Avignon papacy in 1329, 1 year after his death, made a distinction that the condemnation was specifically targeting. He distinguished between God and the Godhead, between the divine as it presents itself in the world, acting, creating, redeeming, named and worshipped, and the silent ground from which even the divine activity flows. He called it the ground of the Godhead, sometimes the desert, sometimes, in Middle High German, the grunt, the ground, the foundation, the deepest place. This ground is, in Eckhart's teaching, beyond all names, beyond all activity, beyond even the distinction between God and creature. The soul has a ground too, a spark, a fundament, the same Latin word, scintilla anime, the spark of the soul. And the deepest claim, the one that drew the condemnation, was this: the soul's ground and the Godhead's ground are the same ground, not similar, not analogous, the same. One ground, expressed differently in each, but one at the depth. The parallel to the vacuum is not in the theological machinery, but in the structural architecture. One ground from which everything arises, which itself does not arise, which is not among the things that flow from it, which is prior to the distinctions, God and world, self and other, matter and void, that organize ordinary experience, and which cannot be reached by adding more concepts, only by the falling away of concepts until what is always already there becomes visible as what is always already there. Eckhart was condemned in part because his precise claim that the soul's ground is the same as the Godhead's ground collapses the fundamental distinction between creator and creature that orthodox theology requires. The ground prior to distinction is prior to the distinction between the one who worships and the one who is worshipped. This is the teaching the condemnation targeted, and it is, in its architecture, the most radical claim in medieval Christian mysticism. Not that the creature resembles God, or reflects God, or participates in God, but that at the depth, both share the same ground, and the ground is prior to both. The languages are different, the methods differ, the structure is the same. Not because Eckhart knew about quantum fields, because the same investigation, pressed far enough, tends to arrive at the same deep structure, even when the investigators share no vocabulary, no culture, no historical connection, and no awareness of each other's work. And this is where the discipline matters most. It is tempting, at this point in the account, to draw the parallel tighter than it should be drawn. To say that the traditions confirm the physics, or that the physics validates the traditions, or that all these independent investigations constitute converging proof of some single underlying reality that both the mystics and the physicists have been circling. The honest position resists this temptation, not because the convergence is not real, It is real. But because what the convergence is evidence of is more careful to state than the popular summary allows. It is often said, in books that line shelves in sections labeled mind-body or consciousness studies or spiritual science, that modern physics has finally caught up with ancient wisdom, that quantum field theory is the scientific confirmation of what the contemplative traditions have known for millennia. This is not accurate, and the inaccuracy is not minor. It is a flattening of both fields into something cheaper than either is. The contemplative traditions were not doing physics before physics existed. Longchenpa had no hypothesis about the Higgs boson. Ibn Arabi was not attempting to describe quantum fields. The Yogacara school was not building a model of vacuum fluctuations. What they were doing was something entirely different, a rigorous, demanding investigation of the nature of experience and reality through methods of sustained attention and conceptual precision that physics does not use and has no equivalent to. The disciplines are different. The questions are different. The methods are different. What physics and the traditions share is not a subject matter. They share a shape in the answer, a structural feature of what they each found, arrived at by completely different investigations. Both found a ground that is primary. Both found a world of appearances arising from that ground. Both found that the apparent solidity and separateness of the world's things is not final. Both found that the ground is not a thing among other things. It is what things arise from. The languages differ. The methods differ. The structure is the same. To claim that physics validates the traditions is to suggest that the traditions needed physics to make them credible, which is condescending to the traditions. To claim that the traditions predicted physics is to misunderstand what the traditions were doing. What is actually the case is more interesting and more difficult. Two completely independent investigations using completely incompatible methods have arrived at structural descriptions that echo each other across a gap of everything. This is worth sitting with, not as a comfort, not as a proof, as a question that remains open and becomes, in the sitting, larger. The field was here before the first star. The ground was here before the first question. What that means? What it means that the investigation from outside and the investigation from inside have arrived at the same shape. This remains, as it should, unsaid. So what does all of this mean? Not for physics. The equations have said what they say, and they will continue to say it regardless of what follows. But for the question underneath the equations, what is the ground? What is it to exist? What is this fabric that rises and lies flat, that holds everything and is made of nothing visible, that has been here since before the first star condensed from it and will remain after the last? There is a movement that happens here after the foundation has been laid and the anomalies have cracked it open and the parallel investigations from two directions have been set beside each other. After all of that, the mind arrives at an edge where more information is not what is needed. What is needed is something closer to standing still, not turning away from the question, standing in it. Letting what has been described settle without forcing it into a conclusion. Without reaching for a comfort the account cannot honestly provide. Let the position be stated plainly, not as conclusion. There is no conclusion available, but as a clearing of ground before the settling in. What is established first. And here the word established is used precisely. These are the things that have been tested, replicated, confirmed across independent laboratories, calculated to precisions that have not been equaled anywhere else in the history of human knowledge, and not yet contradicted by a single experiment. The field is real. The quantum field, the continuous fabric that underlies all matter, that fills all of space, that was primary when Dirac wrote its equations in 1927 and remains primary now, is not a theoretical convenience. It is the best confirmed ontological claim physics has ever made. The particle is derivative. The field is what remains. Every electron that has ever been measured, every photon that has ever carried light across any distance is an excitation of a field that preceded it and will outlast it. The particle arises. The field continues. Lower the excitation to zero, and the particle is gone. The field is still there. This is not an inference. This is what the equations say and what the measurements confirm. The vacuum is not empty. This is among the most carefully tested facts in science. The Lamb shift in hydrogen, measured in 1947, calculated with improving precision since, now confirmed to fractions of a percent, requires a non-empty vacuum to account for it. The vacuum contributes to the hydrogen atom's energy levels. The contribution is measured. The Casimir force, measured in 1997 and since refined to 1% precision, requires a non-empty vacuum. The 12 decimal place agreement of quantum electrodynamics, the most precisely confirmed theoretical prediction in the history of science, requires, at every digit, the contributions of a seething, trembling ground state that cannot be reduced to zero. Remove the vacuum's contributions from the calculation, and the 12 digits of agreement collapse. The void is full. Not metaphorically, measurably. Mass is drag. What we have called the weight of things, the resistance of matter to being pushed, the heaviness that anchors objects to surfaces, is in significant part the measure of how much a particle catches against the Higgs field that fills everything called empty space. This was predicted in 1964, confirmed in 2012 by the Large Hadron Collider beneath the French and Swiss border. The emptiness has been measured, and the measurement shows it is not empty. Space is soaked in a field that was not required to be there by any prior principle, that does not weaken with distance. That is the same in the space between detector components as in the space between galaxies. The ground state of the vacuum is non-local. The Riesch-Schlieder theorem, established in the algebraic framework of quantum field theory, shows that the empty vacuum cannot be factored into independent pieces. The emptiness of space is structurally coherent across all distances, not because something connects the distant parts, because the distant parts were never, in the deepest sense, apart. The darkness in this room and the darkness between the stars are not two separate instances of darkness. They are one ground state, extended. This is what is established. It is already more than the inherited picture of the world contained. It is not everything. What is suggested, what the architecture points toward, without the evidence proving, is more careful to name, because what is suggested is not the same as what is established, and the difference matters more in this domain than in most. The architecture suggests that substance, in the ordinary sense, does not exist, that what appears to be solid, separate, enduring things are configurations of a continuous fabric, not objects resting in space, but the space itself, locally raised. The table is not made of matter resting in emptiness. The table is the field, in this configuration, for this interval. The field that comprises the table, and the field that comprises the air around the table, and the field that comprises the dark between the stars, are the same field, at different tensions, at different heights. The separateness of things is a feature of the configurations, not of the fabric. Separation is surface. The depth is continuous. The architecture suggests that what endures is not the configuration, but the ground. The particle arises and subsides. The field remains. The wave rises and lies flat. The water remains. What this implies about identity, about what the word you names over time, about what persists through the arising and subsiding of each moment of experience. The architecture does not resolve. It suggests the question. The stone that appears to persist from one moment to the next is, on this picture, not a persistent thing, but a persistent configuration of a field that was here before the stone and will be here after. Whether this is true of the pattern that is reading, whether the pattern that calls itself I is a persistent thing or a persistent configuration of the same fabric, is a question the architecture raises and does not answer. The architecture suggests that the one who is asking about the field is not outside the field. The question and the asker are excitations of the same fabric that is being asked about. There is no position available from which to stand outside the field and examine it from a neutral vantage. The examination is the field, examining itself in this local raised configuration for this brief interval. What this implies for the nature of knowledge, for the relationship between the knowing and the known, the architecture does not resolve. It suggests the question. It does not answer it. But the question, once raised in this way, does not easily go back to the shape it had before. And the architecture suggests, this is the most delicate suggestion, and the one most easily misread, that the contemplative investigations described in the previous passage were not doing something entirely different from what physics has been doing, that they were pressing on the same shape from the other side, that the ground Longchenpa described, empty in essence, luminous in nature, unobstructed in its spontaneous display, and the ground that quantum field theory describes, the seething, non-local, irreducible minimum of a fabric that fills everything, have more than superficial resemblance. The structure is the same. This is suggested. It is not established. The difference between suggested and established is the difference between a shape on the horizon and a fact in the hand. Both are real. They are not the same. What remains genuinely unknown is larger than what is established and larger than what is suggested, and it is worth naming precisely because the unknown is not a failure. It is where the question lives. The architecture of what is known has earned the right to say, plainly and without apology, what it does not know. The vacuum energy is unknown. Why the vacuum carries the energy it carries, the cosmological constant, the tiny positive value that drives the universe's accelerating expansion, and not the value the theory naively predicts, which is larger by 120 orders of magnitude, is unknown. This has been known as a problem since the 1960s. No proposed solution. Supersymmetry, the anthropic landscape of string theory, modifications of general relativity, fundamental revisions of quantum field theory, has been confirmed. The discrepancy stands, unreduced, at the center of fundamental physics. It is the largest quantitative failure in the history of science. It concerns the energy of empty space. It has been open for 60 years. Whether the field is real is unknown. Whether it exists in the way a stone exists, with definite properties independent of any description, there between measurements, there whether or not any experiment asks about it, or whether it is a supremely accurate instrument for organizing observations, a calculator of extraordinary power that need not refer to anything beyond the observations it organizes. This is unknown. Both positions are held by serious working physicists. Both positions predict the same experimental outcomes. No conceivable experiment can distinguish between them. What the field is, in the deepest sense, the equations do not say. The equations say what the field does. What the field is, whether it is, in the philosopher's sense, is open. Why any single outcome ever occurs is unknown. The measurement problem has been open since 1926. The smooth, deterministic, continuous evolution of the quantum state does not contain within itself any mechanism for becoming a single definite result. The many worlds interpretation says all outcomes occur. The collapse models say the equation has a term that is yet to be found, a stochastic element at a scale not yet accessible to experiment. Cubism says the question is malformed. Relational quantum mechanics says outcomes are always relative to the observer, and there is no absolute fact about which outcome occurred. No interpretation has achieved consensus. No experiment has decided between them. The mathematics is the same in all of them. What differs is what the mathematics is taken to be about. And that question is not mathematical. It is philosophical. And it is open. Deeper than these, and connected to them, is the question of what the Unruh effect means. An observer at rest in the vacuum finds it empty. An observer accelerating through the same region finds it warm, full of particles, thermally occupied. The number of particles present is not an absolute fact. It depends on the motion of the one who asks. This has been calculated, checked, cross-verified against the mathematics of black hole thermodynamics and Hawking radiation. It is believed to be correct. What it means for the nature of the field, for whether the field is a thing with definite properties or a structure of relations between observers, is not resolved. The result is there. Its implications remain open. And at the bottom of all these unknowns, there is one more, the deepest one, the one that neither the physics nor the contemplative traditions has resolved, and which neither field, separately or together, has the tools to approach without something new. Why is there any awareness at all? Why does the field, in this small place, in this particular raised configuration, know that it is a field? Why is there something it is like to be this pattern of excitations, asking about the fabric it is made of? Why is the asking accompanied by experience, by the felt quality of wondering, the texture of attention, the darkness behind the eyes in a quiet room? The hard problem of consciousness, named so because it does not yield to any method that has worked on softer problems, is not a peripheral question. It is the question that every other question in this account has been orbiting without touching. Physics describes the field. Physics does not describe why any of this is felt. The contemplative traditions approach this question from the inside, from the direction of the experience itself. The Dzogchen tradition says the ground is luminous by nature, that awareness is not something added to the fabric from outside, but a quality of the ground itself, not producible by any process, not reducible to any mechanism. This is a claim about what the ground is. It is not a scientific claim. It is not established in any scientific sense. But it is also not nothing. It is what centuries of careful attention, directed inward past the ordinary mind, arrived at, and what those centuries reported is that the awareness does not seem to be a product of anything. It seems to be the prior condition for there being anything to describe at all. This is where the known stops. Not because the investigation has been insufficient, because the question at this depth may require something that neither the method of physics nor the method of contemplation alone has yet produced. What that something is, Nobody knows. The question remains open. The opening is not a void. The opening is where the ground shows through. And here is where the case against the whole parallel must be named honestly, because it is a real case, and it deserves to be heard as the real case it is. A careful skeptic, a philosopher of science, a physicist who works at the foundations of quantum theory and is wary of popular oversteps, would say this: the human mind is a pattern-matching machine. It was built by natural selection to find shapes in noise, to see faces in clouds, to detect structure and randomness. When the same architectural pattern appears to show up in quantum field theory, and in Dzogchen, and in Ibn Arabi, and in the Isha Upanishad, and in Meister Eckhart, the most parsimonious explanation is not that all these investigations arrived at the same deep truth about the ground of reality. The most parsimonious explanation is that the pattern-matching machine is doing what pattern-matching machines do. It is finding the shape it is already disposed to find in whatever data is available. And there is a more specific version of this objection. The descriptions in the contemplative traditions, the ground that is empty and yet not nothing, the substrate that gives rise to all things without being a thing itself, the fullness that is not depleted, are sufficiently abstract that almost any physical theory about a fundamental substrate could be made to resemble them. The resemblance may be in the abstraction, not in the object. Both the quantum vacuum and the Dzogchen ground are described as empty but not nothing. But these words, in each case, are doing entirely different work. The quantum vacuum is not empty in the sense that it contains no matter. It is not nothing because it has a measured energy and produces measurable forces. The Dzogchen ground is not empty in the sense that it is not a fixed, reified thing. It is not nothing because it is described as luminous awareness. These are not the same claim. They share words. Whether they share a referent is precisely what is in question. This objection has weight. It should not be dismissed. It is what careful thinking requires in the face of any convergence that arrives too easily. And yet the objection, while real, is not the last word. Not because the parallel is proven, but because the objection applies to a weaker version of the claim than the one being made here. The claim is not, these traditions said something vaguely similar to quantum field theory. The claim is more specific. The claim is that several independent investigations, using completely incompatible methods across 2.5 millennia and multiple cultures with no contact with each other, each arrived at a structural description in which a ground is primary. Appearances are derivative, and the ground is neither empty absence nor a thing among other things, but a third category that has no name in ordinary language. The Yogacara tradition built a precise technical account of the substrate, warned against specific misreadings of it, developed formal debates about its nature over centuries. The Dzogchen tradition developed a precise technical distinction between the ground, ordinary mind, and pure awareness, with 3 specific qualities named and carefully preserved across a transmission lineage. These are not vague. They are as precise as the contemplative vocabulary allows. And what is precise about them does not vanish when the abstraction is reduced. The parallel stands, not as proof, not as validation, as resemblance that is more than coincidental and less than conclusive. That is as far as the honest position goes. The hidden teacher does not take the listener past that point. The point is already far enough, and you have stood in front of this question, not with equations and not through decades of formal contemplative practice, but you have felt in some ordinary moment, in the stillness before sleep, in the interval between thoughts, in the strange persistence of a feeling that the room around you in the dark is not quite empty, that the dark has a quality that is not the mere absence of light, something that this account has been circling. The physics has a name for it. The traditions have names for it. But the feeling came first, before any name, in ordinary experience. Something is there, in what looks like nothing. The room is not empty. The dark between the stars is not empty. The space between the hand and the table is the most precisely known nothing in the history of science. And it is not nothing. What this feels like in the body before it has any name. The quality of attention that notices the room as not empty. The strange awareness of being aware. This is not nothing either. The contemplative traditions spent centuries examining this from the inside. What they reported is not conclusive, but it is consistent. The awareness does not seem to be produced by anything in experience. It seems to be what makes experience possible. Whether this is what the ground is, whether Longchenpa's luminous ground and the physicists' seething vacuum are different descriptions of one thing, is not known. But the question is real. And you are the question in this form tonight. The field does not become more real when you know its name, but knowing something of its structure, knowing that the darkness in this room seethes with a minimum activity that cannot be switched off, knowing that the fabric you are made of and the fabric of the space around you are the same fabric at different tensions, knowing that the one who is wondering about the field is not outside the field, but is the field in this configuration, asking. This is a different quality of knowing than not knowing. What it changes is not the field. The field ran by the same equations before the knowing and will run by them after. What it changes, if anything, is the sense of standing in relation to it, of being rather than observing, of being inside what is being asked about rather than positioned across from it, and the promise in the title that brought this account into being, that once you truly understand the quantum field, your reality shifts instantly. That promise is true, but it runs in the opposite direction from the one the title intended. Nothing shifts because you command it. Nothing shifts because you align with the field or project intentions into it, or raise your frequency to attract what you want. The field does not take requests. It has been running by the same equations for 13.5 billion years before any mind formulated any intention at all. The field does not listen, and the one who would do the commanding, the separate self positioned outside the field, issuing instructions to it, does not exist in the way the commanding requires. There is no you over here and field over there. There is only the field, and in this small place, the field has briefly raised a pattern that is wondering what it is. What shifts, if understanding genuinely arrives, is not the circumstances. It is the sense of who is asking. The wave does not control the water. The wave is the water briefly raised, asking what water is. That recognition, when it lands without resistance, without the overlay of what it should mean or what it should produce, is what the title was pointing at, not the rearrangement of circumstances, the recognition of what was already the case. Nothing shifts because you command it. Everything is already the shifting. And so the account arrives where it began, the dark room that is not empty, the fabric that fills what looks like nothing, the field that was here before the first star and will be here after the last. Something has been established. The vacuum is real and measurable and full. Particles are the field's excitations, not things. Mass is drag against a field that saturates empty space. The ground state of the vacuum is correlated across all distances, not divisible into independent pieces. These are facts. They are confirmed. They do not depend on anything the contemplative traditions say, and the contemplative traditions do not depend on them. Something has been suggested but not established. That substance is process. That separation is surface. That the one who asks is the same fabric as what is being asked about. That the investigations from outside and from inside converge on the same shape. These are real suggestions. They are not established facts. They deserve to be held as what they are, suggestions pointing in a direction, not arriving, and something remains genuinely unknown. Why the vacuum energy is what it is, whether the field exists between observations, why any single outcome occurs, and the deepest gap, why any of this is felt, why the field in this raised configuration is accompanied by the experience of wondering. That gap is real. It has not been closed. It may be the most important question there is. None of this has been resolved. The account does not resolve it. The account only establishes where the question has been brought to from two directions by two kinds of investigation that neither knew about each other's work. The ground is primary. The appearances are derivative. The fabric is one. The separate things are not finally separate. And the one who asks about the fabric is the fabric, briefly raised, briefly luminous, briefly asking. And when the small pattern that has been listening finally lies flat again, the field will not lose anything. It will only be still, full in the dark, the way it was before the first star and will be after the last. The ground was never empty. It was only quiet.